Hi, I am Jesús Díaz and this is the video about the sound in the music of the series Sight Singing Theory 101 from the Do Re Mi Tutor project. Video at the end of which we will have acquired, remembered or reviewed some basic ideas about the musical notes and their most commonly known properties, as well as a rather obscure and much less discussed feature of them that nevertheless happens to be the cornerstone of our perception of music, its tonal tension. Besides, we will find out why we use just a handful of names for so many notes used in music, and acquire a pretty clear idea about how these notes are organized and why. In the way, we will present briefly the concept of a scale and explore the phenomenon of consonants. We'll begin in a few seconds.
Sol, la, sol, si, do, si, la, re, do, la, si, do.
Let's begin by considering that in its pure essence, music is only sound organized in time, with time as the organizing context and sound as the raw material. Sound whose individual musical emissions are perceived as fixed tones, known specifically as notes, that, besides a definite pitch, have a name and physical properties like duration, timbre, volume, and an often little discussed and rather psychological attribute, but perhaps its most important musical trait, its tension. Let's explore them one by one. The pitch of the notes, which is metaphorically treated as their height, is their unique and invariable property that permits ordering them in collections that individually receive the name of a scale. One example of such a scale is the series of 8 notes we will hear next, represented graphically by these flash circles, aligned vertically just to assure a sense of the meaning of pitch or height, in which the vertical position of each note equates to its pitch. Let's listen closely to how they sound while flashing in turn from the lowest to the highest. This particular scale is extremely important, for it contains absolutely every pitch we must learn to recognize, evoke, or sing, which is, believe it or not, incredibly easy with a little of well-conducted practice, as we will see as soon as we start the series of exercises. You'll be surprised. Now, just to become familiar with them, let's repeat the notes, or now more formally the scale, from the highest to the lowest. The main objective of the last experience was simply to ensure a good understanding of the concept of pitch, but there are much more notes than those 8. Let's see how we can organize them. All these notes we're hearing and watching represented by these smaller circles are still just a portion of the total available. However, while each of the several dozens of them clearly has a different pitch, all we need to name them all is some few names. To find out how that is possible, let's go back to our first scale. Now, with the same 8 original notes aligned horizontally, we'll hear the pairs that the first note forms with each of the others, first sequentially, and then simultaneously, and we'll find that from the second to the seventh, they leave no doubt that they are absolutely different from the first, but the eighth represents a special case that is worth close attention. Let's listen. Did you hear? The eighth note sounds as if it were just a different version of the first. Let's listen again. This extraordinarily noticeable resemblance, in spite of the obvious difference in pitch, is the result of some kind of affinity between notes known as consonants, which, although may be found in other combinations of notes in lesser degree, it reaches its maximum level, every 8 of them, in scales like ours, regardless of the initial note. But let's check this out. This time we will hear our 36-note scale again, but by groups of notes that are 7 positions apart like this, starting with each of the first 7. Each of these 7 resulting groups is considered a pitch class. Listen carefully to how all the notes in each pitch class sound sort of the same due to the consonants among them. Well, grouping the notes in just 7 pitch classes has been a huge step towards organizing them. Now, let's find out about their names. The consonants just presented happens to be a very lucky circumstance, for as long as it originates only 7 different pitch classes and all the notes in the same class sound so similar, we can give all the notes in the same class the same name, hence needing only 7 names for all the available notes. These names happen to be the first 7 letters of the alphabet, in the order we know them, but starting in C. Returning to our 8-note scale, these names correspond to the predefined pitches we hear from the first 7 notes, the 8th being another C, a pretty consonant repetition of the first as we can now understand, usually included in scales like this for oral roundness. Now that we know their names, let's try to sing them to become familiar with them. C, D, E, F, G, A, B, C. C, B, A, G, F, E, D, C. It is opportune to mention that the difference in pitch between 2 notes is formally called interval in a general manner, but receives a specific ordinal number as a name depending upon the number of notes that comprises, both extreme notes included. So, the interval between 2 consecutive consonant notes, that is to say, with the same name, embracing 8 notes, receives the name of octave, from the Latin octavus, meaning eighth. So, one example of octave as the interval is the distance between these 2 C's. And another meaning of octave, this time as a group, is the set of all the notes contained within an octave as our interval, like the first 7 notes of this 8-note scale, because strictly speaking, this 8th or last note is rather the beginning of the next octave. But there's another set of names, or more precisely syllables, to name the notes, which are also shown here and whose employment instead of the letters receives the name of solfege. To help us to learn them by rote, these solfege names will be the ones shown in the first exercises, although I would recommend to become familiar with both series of names. It is no rocket science. However, you may sing them as you prefer. The key point here is the comprehension. But let's practice with these other names too. Do, re, mi, fa, sol, la, ti, do. Do, ti, la, sol, fa, mi, re, do. Now, in order to get a deeper sense of the importance of the consonants, let's sing the 36-note scale again, only that it exceeds 5 octaves, and most of us have a voice range of only 2 at the most. And here is where the consonants comes to our help. As long as all the notes in a pitch class are so consonant, we may sing all the scale in our most comfortable octave. Just let me show you how, and when you are ready, join in for as many repetitions as you like. Do, re, mi, fa, sol, la, si, 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 do. How about it? Did you notice that every 8th note it seems like starting over? Do you realize now why 7 names are enough? Well, let's move on to the duration. Although the duration of a note is logically just the time elapsed from its start to its end, to discuss this property we need to explore in certain detail the particular time measurement system that music employs, which will be covered in the next video. Don't miss it. Another properties of sound in general, and therefore also of notes, are, on the one hand, the timbre, which allows us to identify the instrument or voice that generates it, though this is practically irrelevant for music reading, given that music for different instruments or voices is written separately. And, on the other hand, the volume, which is simply how loud a sound is, but this will be discussed at a more advanced level. The truly important characteristic is what follows. Do not miss it for anything. Have you ever wondered how we can recall melodies or what empowers us to sing any familiar tune, note after note, without any mistakes? Well, first the bad news. It is highly unlikely that we can remember any tune in the exact pitch we learned it, because our skill to remember exact pitches is generally extremely poor. But the good news is that it doesn't matter at all, because instead of that we are amazingly skilled to remember chains of tonal tensions, and that is what musical ideas are composed of. This deserves a wider explanation. Let's bring back our first scale with no names or whatsoever and listen to it again. Now let's listen to it starting on a different pitch. And now on another. Did you feel how the idea or the melody seemed to be the same in all three performances? That's because our brain doesn't really care about the accuracy of the pitches, but it does attentively care and very much about the accuracy of the pitch relationships among all the notes in any musical idea. Remembering those relationships, we are brilliant, unbeatable, and that is why we can easily remember, recognize, or sing tunes. But we can make ourselves even a lot better by learning to identify those relationships, or more properly called, tonal tensions, skill which is the main requirement in sight reading. How? From the very first exercise of the next series, I promise. For now, I just hope to have awakened your interest, for before beginning to develop such a skill, we need to acquire or remember some other ideas about the timing and writing of music. I'll see you in the next video, in which we'll have more fun exploring the timing. Bye bye.